Welcome to Brain Vision.
Consider a charge Q. We have a charge Q whose magnitude is equal to plus 6.00 microcoulomb. Well, it is moving at a constant velocity. Well, velocity of the charge is equal to 8.00 times 10 to the power 6 meter per second. Right, and the charge is moving in the positive y direction, so velocity is in the positive y direction, and relative to a reference frame. Let's do part A. Well, first we need to find a magnetic field vector that this charge produce. 8x is equal to 0.500. Y is equal to 0 and z is equal to 0. Well, at the instant when the point charge is at the origin of this reference frame, the magnetic field is given by, well, magnetic field vector is given by mu naught divided by 4 pi times q times v cross r divided by r square. Here, r cap, which is a unit vector, is equal to vector r divided by the magnitude of vector, right? Here, this r vector is the vector from the charge to the point where the field is calculated. In our case, right, r vector is equal to 0.500 meter I cap dot r is equal to 0.500 meter, and v vector is equal to, so v vector is equal to 8.00 times 10 to the power 6 meter per second in the j cap direction, right? Now we can write v cross r, right? It's the cross product of v and r is equal to v, the magnitude of v times magnitude of r times j cross I cap, and that is equal to minus vr times k cap, right? It's minus v times r times k cap. And now plugging values, so magnetic field vector v is equal to minus 1 times 10 to the power minus 7 multiplied by 6.00 times 10 to the power minus 6 multiplied by 8.00 times 10 to the power 6 divided by 0.500 whole square, and that is equal to minus 1.92 multiplied by 10 to the power minus 5 Tesla in the k cap direction. All right, now let's do part B. Now we do the second part. Well, 8x is equal to 0, y is equal to minus 0.500, and z is equal to 0. Well, using v cross r is equal to minus v j cross j, well, that is equal to 0. Therefore, magnetic field at this point is equal to 0. Now let's do part C. Now the points are x is equal to 0, y is equal to 0, and z is equal to plus 0.500, right? Now we have v cross r. Well, v cross r is equal to minus v times j cross k cap, right? and that is equal to V times R times I cap. Now let's plug in numbers. Then magnetic field vector is equal to 1 multiplied by 1 multiplied by 10 to the power minus 7 times 6.00 times 10 to the power minus 6 multiplied by 8.00 times 10 to the power 6 divided by 0.500 whole square. Therefore, magnetic field vector B is equal to 1.92 times 10 to the power minus 5 Tesla in the I cap direction. Now we do part D. Well, the points are x is equal to 0, right? We have x is equal to 0. Y is equal to minus 0.500 and Z is equal to plus 0.500, right? Now let's plug in. Let's find out the magnitude of R. Well, magnitude of R is equal to root 0.500 square plus 0.500 square. Well, that is equal to 0.7071 meter, right? And further, we find V cross R. Well, V cross R, right, is equal to V into 0.500 meter into minus J cap cross J cap plus J cap cross K cap, right? And that is equal to 4.00 times 10 to the power 6 meters squared per second in the I cap direction. Now let's find out magnetic field. Well, magnetic field vector is equal to 1 times 10 to the power minus 7 times 6.00 times 10 to the power minus 6 multiplied by 4.00 times 10 to the power 6 divided by 0.7071 whole square. So magnetic field vector B is equal to plus 6.79 times 10 to the power 6 Tesla in the I cap direction.